Till now we have discussed about some spatial characterizations of vectors, and now we will move towards some spatial vectors, and these vectors will be like the building blocks of whatever we will do in the whole course. That means if you are able to understand and practice with these basic vectors, the fundamental building blocks, then everything, all the problems can be solved with the help of these vectors. Now if I want, so the first of them is the unit vector. Okay, just for the completeness I am saying that I am assuming that all of you know this unit vector, but just to make the list complete, exhaustive, so I am writing it. And unit vector, how do you calculate that? So, given a particular condition, okay, say you are given with a pictorial representation of any vector, so like that. Now you are quite comfortable with representations of vector. So, I am now showing you one type of representation which is generally given, say in the y direction this much, in the x direction slightly it has to be changed, in x direction and in z direction. Okay. So, that means you are moving. So, this is a 90 degree, this is a 90 degree, and generally in the book if you see it will be shown like complete cuboid like that. So, like that, from the tail to the tip of the vector, you can consider that to be the main diagonal of a cuboid, and that cuboid's dimensions will give you the information about the unit vector. So, suppose this is written say A, this is B and this is C, then this will be the unit vector. Suppose the vector's name is what do I give, say V, then unit vector V. You remember we always told that when the actual vector is capital V with a bar over that, the small v will denote the, with a hat over that, will denote the unit vector in that direction. So, that will be equal to what? Now, first you have to represent this arrow with proper unit vectors. So, now suppose this is I, these are j, and this is k. Okay. So, I, j, k, the unit vectors in the orthogonal direction x, y, z are I, j, k. Then unit vector in the direction of this, which is v, will be how much? How to calculate that? Now, you have to first represent v as what? Say I will say a, but a is in the direction of j, right. So, a j plus, now b in the negative direction. So, I will say b times minus I plus c times k. So, this is the representation of that vector, but unit vector if you want to write, you will have to divide by the magnitude of this, which will be nothing but a square plus b square plus c square under root. Okay. So, that means the whole vector, you now know how to represent it, because again to just remind, this can be thought of as sitting here with the dimension a, b, c. Sometimes it a bit confused, some students get confused, so I am just repeating. Now, so this will give you the unit vector in the direction of v. So, and then this is one of the tools which you will be using n number of times. Any problem, if we pick, this is the tool of finding unit vector in any particular given direction, will be used so many times that you can't even believe now. Okay, that's one. Then second thing which come into our list is say position vector. Okay. Now for position vector, you have to have a coordinate system somewhere with its origin, and any point you pick, say point P in the space in that particular space, then the position vector is the vector from the origin to that point. That means this vector is the position vector, and we will denote that as a what, rho maybe. In general, we will denote rho as the position vector of any point P. So, from origin to that particular point P. So, that is the position vector. And then the third that comes in our list is the displacement vector. Now, displacement vector is a vector that is pointed from one point to the other in the space of consideration. Suppose there is the point P and you have another point, say Q here, and this vector P to Q is the displacement vector from P to Q. So, we can tell that, denote that by rho P Q. Okay. Now, that will be given by, say, if you have the position vector of Q here, position vector of P here, and you will get displacement vector rho P Q to be equal to rho Q minus rho P. Okay. So, that is how you will define the displacement vector. So, these are the most fundamental vectors, three vectors, and using them now we will develop some more sophisticated vectors, which are again building blocks will be for solving problems. Okay. But let us first be very clear about what these three vectors mean and how to write them. Okay. That should be clear.